So number 11 on our homework, we have x to the fourth minus 19x squared plus 48. Obviously, we're not going to use factoring by grouping. If I had 4 or more, 6 terms, I would try factoring by grouping. Is there anything in common in all 3 terms that you could pull out the GCF? No. And not only that, guys, here's the very first time in our homework that we have an equation equal to 0 that we need to actually solve. Okay? Now, this is going to be a little weird. We're going to have to pretend that this is an x squared and this is a regular x. Now, you could do that because this is a 4 and a 2. So you're going to pretend that it's an x squared and an x. In other words, if it were an x squared and an x, how would you handle this factoring? You would simply do this, parenthesis, 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 parenthesis equals 0. But instead of x times x, right, because x times x is x squared, and that's not an x squared. So what am I going to put right here and here? 2. That's right, 2. You'll put a 2 right there. So this is the setup for these types of questions. If it's factorable, it might not be factorable, it might be prime. But let's think about this. What times what is the c value that if you add together is the b value? So how could we get 48? Well, it's 1 times 48. It's 2 times 24. It's 3 times 16. It's 4 times 12. So do we already see the combo? Which one are we going to be using? 3 and 16 is the correct combo. However, if I add the 3 and the 16, I get positive 19, and this is a negative 19. So I know I need to just switch the signs on the 3 and the 16. So it's really going to go in as negative 3 and negative 16. Are you with me? Yes. Okay. So we're kind of applying the old factoring methods that we used to use at the beginning of the year, and we're giving them slight twists, right? Like the factoring by grouping, we used to do it with 4 terms. We're going to be doing it with 6 terms now. The what times what is C, that if you combine together is B. Same concept, but you have a 4 and a 2 right here. Now, if you had a 5 and a 2, you couldn't do this. It has to be a 4 and a 2 right there. Okay, now let's continue solving this thing because we already rewrote it as something times something equals 0. So I'm going to split it now using the zero product property. X squared minus 3 equals 0. X squared minus 16 equals 0. I hope you guys are keeping up. This is part of your homework anyway. And I need to solve both of these equations. How do I solve this first one? What do I do? Plus 3. Yes, add 3. Thank you. And you're going to end up with x squared equals 3. Now, how do you get rid of a square? You square root. However, when you apply a square root in an equation, you have to put a plus minus in front of your answer. Again, an old skill that we've done. Square rooting to get rid of squares. So our answer here is actually 2 answers. X equals a positive square root of 3 and a negative square root of 3. That's 2 answers so far. Let's go to the other one. We're going to go plus 16 on both sides. So you're going to have x squared equals positive 16. And right here we're going to square root and square root. And of course x is going to equal, again, 2 answers, plus or minus 4. So you actually have 4 answers right here. A nice 4 and a nice negative 4. And we also have a positive square root of 3 and negative square root of 3. Those are values that are like 1 point something, but they're still decimal values. They're still real numbers. If I were to graph this on a XY plane, it would cross 4 times. We already knew that. For the degree of 4, 4 answers. Since we skipped number 9, let's jump back to number 9. Yeah? So we have number 9 here. Is there a GCF I could pull out from both terms? Is there something in common with the 8 and the 125? Answer is no. Can't pull out a 2, can't pull out a 3 or 5, nothing like that. The variables C and D, totally different variables. I can't pull out anything. Always try to pull out the GCF first. There's no GCF here to pull out. So what am I going to do next? I need to recognize that this is a perfect cube term and this is a perfect cube term. Okay? So I first need to rewrite it as something cubed minus something cubed. That way I could identify my A and B value. my A is not 8, my B is not 125. As a matter of fact, my A is not C either, and my B is not D either. What belongs in here to the third power that'll give me 8C to the third? 2 to the third is just 8. But I need it to be 8C to the third. 2C, right? So a 2C belongs right here. Now how about the 125D to the third? What belongs in here that'll give me a 125D to the third? What was that? 5D. Exactly. 5D times 5D times 5D is 125D to the third. So what have we done here? We have identified our A value and our B value, and now we're able to use the difference of 2 cubes formula. It's funny, on all these examples, we've only used the difference of 2 cubes instead of sum of 2 cubes. Anyways, in case you forgot, the difference of 2 cubes, it's a binomial times a trinomial. And the binomial is the easiest part because it's going to look exactly like this without the cubes. It's just the A minus the B. In this case, 2C minus 5D. So I write that down in the binomial, 2C minus 5D. Are you with me? Okay, now the trinomial is going to get a little weird. Let me make these bigger. Now, the trinomial in the formula, let me write down the formula. So the formula is right here. So we know that we need an A squared right here, and we know that this is A, but you need to use parentheses, guys. So instead of A squared, I'm going to write, instead of A squared, I'm going to write parentheses squared, and I know that my A value is 2C, so I'm going to put 2C right in here. Now it's important that you use parentheses, because if you don't, you're going to think that it says 2C squared, and at the end of it all, it does not say 2C squared. It's going to say 4C squared. Does that make sense? Okay. And now, again, let's use parentheses for the plus A times B. Let's just do that with parentheses. And, of course, we're going to have a 2C times a 5D. That's ugly. I apologize. 2C times a 5D. And at the very end, we're also going to have plus B squared, but I'm going to put the square or the parentheses right there and the square on the outside, and my B value is 5D. 5D. So now that I already have it all set up the way I need it to be, I'm going to delete the formula itself to make more space, and let's work on simplifying this answer. It's going to be 2C minus 5D, and over here it's going to be 4C squared, and 2C times 5D, that's going to be positive 10, because 2 times 5 is 10, and C times D is CD. And at the very end, what do I have? What's 5D times 5D? Plus 25D squared. Ladies and gentlemen, this is the completely factored form of the original difference of 2 cubes up there. So on number 13, we're going to be using the sum of 2 cubes formula. And the sum of 2 cubes formula is a binomial times a trinomial, exactly what you see here. The key to applying the sum of 2 cubes formula is to be able to identify your A and your B. So this right here, this right here is not part of the formula, but it's important to do this to be able to identify your A and your B value. So up on the original question, as a matter of fact, I copied it down wrong. It's x to the third plus 27 equals 0. Okay, so this is an equation that we need to solve. That's what they ask us to do on number 13. So we're going to use this formula to factor. And why are we going to factor? To be able to get multiplication. And because it's equal to 0, we're going to be able to split them and solve. So what I want to do is I want to get this formula and just move it out of the way, since we already know it. Again, we first want to set up the parenthesis to the third power plus parenthesis to the third power equals 0. That way we could identify what our A value is and our B value. So x is really our A value and 3 is really our B value. And again, once you have it set up and you know your A and your B, it's simply going to be a binomial times a trinomial. The binomial is exactly the same binomial you see here without the cubes. So it's simply going to be a x plus 3. And remember, on your trinomial, you have your first term squared, which is x squared, and your last term is over here squared, 3 squared, and your middle term is both a and b multiplied together, so that's going to be x times 3 multiplied together. We also said that the squared term is positive, and this squared term is also going to be positive, so you could put a plus right in front of there. The only trick is if you started with the plus sign, because it was a sum of 2 cubes to start with, then this middle term has to be minus, has to be the opposite. Okay, anyway, this is in the factored form now. The only thing you can do is clean it up a little, the trinomial part at least. So you're going to have x plus 3, x squared minus 3x plus 9. Okay? And remember, this was an equation equal to 0, so we still have it equal to 0. And now we truly have something times something equals 0. So we're going to use the zero product property to split and solve. So let me just scroll this up a little. And we're going to have the x plus 3 equaling 0. And we're also going to have x squared minus 3x plus 9 equaling 0. So I want to put a little line to separate my work here. It's obvious that x is going to equal negative 3. And that's one answer to the original cubic equation. Now we need more answers. Let's go over here. And you might think that you could factor by going parentheses, 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 parentheses equals 0, x, and x. But the truth is it's not factorable. So you can't do that. What times what is 9 that if you add together is negative 3? It just doesn't work. So what we need to understand is when all else fails on a quadratic equation, because this is quadratic now, x squared plus something x plus a number equals 0, you could always use the quadratic formula where your a value is 1, your b value is negative 3, and your c value is 9. So what I'm going to do is scroll this up, make some space. I want to use a quadratic formula for this part right here. There it is. And of course, when you use the quadratic formula, use parentheses to insert your a, b, and c values. So let's plug in our a, b, and c values in there. Our b value is negative 3, the a value is 1, the a value is 1, the c value is 9. And now we could focus in on simplifying this. So this will be 3 plus minus, and on the inside of the square root, that's where it gets fun. You have a 9, and negative 4 times 1 times 9 is a minus 36. And when we combine the 9 minus 36, we get a negative 27, and it's over 2. Okay, so what we need to do now is focus in on simplifying the square root of negative 27. For example, the square root of negative 27, well, first of all, that negative becomes an I on the outside, so I'm doing this work on the side. You end up with square root of 27 now instead of negative 27. And 27 breaks down to 9 times 3. And if you split the root and bring down the I, you're going to end up with I times 3 times the square root of 3, which means that you really have 3I square root of 3 instead of the square root of negative 27. Once again, this is all done just to be able to replace the square root of negative 27 with that 3I square root of 3 value. So there's your answer. However, because there's an imaginary value, it might be written like this. You split the denominator of 2 to each part, so you would have 3 square root of 3 over 2 with the I at the very end. So this is an acceptable answer, but this is way better. And we also have the other answer, which is the minus 3. So all this work is the answer. So you have this answer up here and these two answers down here.